We start out talking about direct variation and proportion as we begin chapter 8. And here are some key words to look for direct variation. Look for the phrase y varies directly with x, or sometimes we leave out the directly and we say y varies with x. Or we'll say y is directly proportional to x. We add another word. Sometimes we leave out the direct because it's assumed and we say y is proportional to x. And any of these phrases that you see, you want to replace with the equation y equals some constant k times x. And k is called the constant of variation. Sometimes we call it the constant of proportionality. So let's take a look at an original problem here, example number 1. I suggest try to follow along this way. I know there's another way to do this without a two-step process. But please follow this way because when we get to inverse variation and joint variation, it'll be the same process. So first of all, we see find the constant of variation, and we see the key words where y varies directly with x, comma, so that means pause. So let's write down y equals k times x. And let's fill in the rest of the information here. We know that y is 32 when x is 2. So replace y with 32 and replace x with 2. And in this case, they want us to find k, the constant, so we'll divide both sides by 2, and we find out that k is 16, and then find the equation they're also looking for, of variation. So we replace k with 16 and say y equals 16x. Now, in that case, we're just looking for the constant, and that's a one-step process. But in most of the examples we're going to do, we're looking for a two-step process because we're looking for the variable again, and not just the constant of variation or proportionality. So let's take a look at this next example. We see the key words y varies directly with x, comma. So let's pause and part 1, let's find that constant of variation on our way to finding out what they're asking, which is to find out x. So y varies directly with x becomes y equals some constant k times x. As we read on, y is 15, x is 24, comma. So let's pause there. Replace y with 15, x with 24. Divide both sides by 24, and we find out k, the constant of proportionality, is 5/8. Now we're not done because they want us to find out x when y is 25. So this is a two-step process. For part 2, let's take the equation y equals k times x, replace k with 5/8, and we get y equals 5/8 times x, since 5/8 is our constant. Then let's read on. Find x, so that stays a variable, when y is 25, so we replace y with 25. Now we'll solve for x, multiply both sides by the reciprocal, 8/5. On the right, that leaves me with x. On the left, 5 and 25 cross reduce to 5. 5 times 8 is 40, and we've solved the problem. Now, I know in Algebra 1 you learned how to solve this as a one-step problem, so again I'm going to remind you, let's make this a two-step problem, because as we get to inverse variation in our next lesson and joint variation, you won't have to learn anything new if you're following this process. Alright, sometimes we have real-life situations expressed in sentences. Electric current in amperes in a circuit varies directly with the voltage. When 12 volts are applied, the current is 4 amps. What's the current when 18 volts are applied? Now, since I'm not your science teacher, I'd suggest that maybe we want to try to pare this down to the most crucial information. And so we can cross out electric current, keep the I, since we're not worried about units for science purposes. I is measured in amps, that's great. In a circuit, we can cross that out and leave I varies directly with V. We can cross out the rest. And if we look on 12 volts, well, that means V is 12. 4 amps, that means I is 4. What's the current? That means solve for I. And when 18 volts are applied, that means V is 18. So let's start with the first sentence, what's left of it. I varies directly as V. So that's I equals our constant of proportionality times V. Next sentence, V is 12. I is 4, so let's stop at that period. Substitute 4 in for I, substitute 12 in for V, and let's solve for our constant of proportionality, even though it doesn't ask us to. And we find out that that's 1/3. Part 2 of the problem then, we found k. Let's replace k with 1/3. And let's read the rest of it. What's the current? Well, that's I, and that's what we're solving for. And substitute 18 for V, and a very simple calculation then. 1/3 of 18 is 6. Now, I is measured in amperes. If you want to write that down, it'll make your science teachers happy. But as far as I'm concerned, this is math. If we get 6, we're good to go. Alright, so there's one look at a real-life situation expressed in sentences. Let's check out another one. It says the period of a pendulum is directly proportional to the square root of the length of the pendulum. If the pendulum 64 centimeters long has a period of 1.6 seconds, what's the period of a pendulum 1 meter long? And that's what we're looking for. So let's try to pare this down to the essentials. And they're not giving us variables, so why don't we just choose P for the period? If you're in science, you can replace it with whatever you like. Forget of a pendulum, but let's keep P is directly proportional to the square root of the length, and we'll call that L. Forget about the pendulum for a second. If the pendulum 64 long has a period of 16, what is P when the pendulum is 1 meter? Now, I put the parentheses in this problem myself to be careful, because they're using different units here for length. One is 64 centimeters, and then the other one they used 1 meter. So I'm reminding you that there are 100 centimeters in a meter. Let's start with our equation. P is directly proportional to the square root of the length. So P equals a constant times the square root of L. We fill in the numbers that we know, so that length is 16 and time, the period, is 1.6. So replace P with a 1.6 and L, substitute 64 in its place. Square root of 64 is 8. Divide by 8. And we find our constant of proportionality is 0.2. So for part 2 of the problem, let's substitute in 0.2 instead of K. We know what our constant is. And let's read on. What's the period P? Well, we're going to solve for that. When length, now we're not going to put 1 because we have to be in the same units. So let's put 100, substitute 100 for L for the length in centimeters. And simplify this. The square root of 100 is 10. 10 times 2/10 is 2. And if you want to write down that the period is measured in seconds, that's great. So the period is 2 seconds for that pendulum to oscillate with a length of 100 meters. Alright, the next one talks about something called a geometric mean. A, B, and C are positive numbers. Then we know that A over B is equivalent to B over C. In that case, B is called the geometric mean of A and C. And this is a review from geometry a little bit. Remember, A and C were the extremes. B was the means, the numbers in the middle. And you may not know that we call them the geometric mean, but we studied in geometry, so it's the geometric mean. Very simply, find the geometric mean between 4 and 20. So 4 is to B as B is to 20. Solve that. We can cross multiply, and then we get B squared is 2 times 4, which is 80. So we multiply the product of the extremes equals the product of the means. B squared is 80. Of course, we're going to square root both sides. Square root of B squared is B, and the square root of 16 is 4. Square root of 5 cannot be simplified, so that's the geometric mean. So that's our first look at direct variation and geometric means.